Imagine this scenario for a second. You get a phone call, right? It's your bank.
Always a stressful call to get.
Exactly. And the voice on the other end is warning you about some suspicious charge on your account.
Right.
And when you interrupt them, maybe you ask a question like, wait, what was the vendor? They pause naturally. They say, they shuffle some digital papers around, and their tone perfectly matches that exact urgency of a fraud alert.
You buy it completely.
You buy it 100%. But now imagine that quote-unquote person is actually just a server rack in a data center.
Yeah.
And while you are talking to it, another entirely separate AI agent is natively moving the mouse on your laptop.
Right. Opening your terminal.
Exactly.
Yeah.
Opening the terminal, executing a zero-day exploit, and just quietly rewriting your operating system.
I mean, it sounds like speculative fiction, but
It really does.
But it's the exact engineering reality we are sitting in right now.
Yeah.
The paradox of the current technological landscape is that as AI becomes completely invisible in our daily lives, like blending flawlessly into our phone calls and our software, its behind-the-scenes consumption of resources, of data, of power is becoming violently explosive.
It's wild.
The quieter it gets on the surface, the more ravenous it is underneath.
Well, welcome back, everyone, to the third deep dive in our AI Core series. If you've been following along with us, you know we've been tracking the evolution of these systems.
We definitely have.
But today's stack of research, the leaked blueprints, the corporate data we have to go through, it reveals a really profound paradigm shift.
It's a total pivot.
We are officially entering what we're calling the autonomous agent economy.
Right.
We are so far past chatbots at this point.
Oh, way past.
We are looking at a world where AI commands massive corporate budgets and honestly fundamentally threatens global cybersecurity. So we're going to unpack this escalation today.
And we should start with that voice on the phone you mentioned.
Yeah, let's start there. Because the boundary between human and machine, it isn't just breaking down, it has completely evaporated.
It has. And that evaporation, it really starts at the biological level.
Right.
If we look at Google's new Gemini 3.1 Flash Live, which is their entirely voice-focused real-time dialogue model, the entire engineering philosophy hinges on a single metric.
300 milliseconds.
Exactly. 300 milliseconds.
Because 300 milliseconds isn't just some random tech benchmark. That is the biological speed limit of human conversation.
Precisely. I mean, evolution has hardwired you and I to expect a response within a third of a second.
Right.
When we're talking, the cognitive turn-taking happens instantly. We anticipate the end of each other's sentences.
We're doing it right now.
Exactly. But if a delay stretches to, say, 400 or 500 milliseconds, your brain immediately flags the interaction as anomalous.
It feels wrong.
It triggers that awkward feeling of like a bad satellite connection on a news broadcast.
Oh, I hate that.
Right. Or it shatters the illusion entirely because you realize you're just waiting for a processor to compute tokens.
You end up stepping on each other's words. You say, hello, and they say, yes, I'm here, but you overlap.
And the presence is ruined.
Totally ruined. But Gemini 3.1 Flash Live has reportedly just obliterated that latency threshold.
They really have.
And to prove it, they didn't just test it in some sterile, quiet lab environment. They ran it through the complex funk bench.
Which deals with multi-step audio reasoning.
Right. And they ran it through Big Bench Audio, which is this gauntlet of 1,000 audio logic questions.
And it crushed both of those.
It crushed them. But the metric that actually made my jaw drop when we were looking at the sources was the Scale AI Audio Multi-Challenge.
Oh, yeah. Because that test is specifically designed to measure chaos.
Chaos.
It doesn't test clean audio at all. It tests how an AI handles interruptions, hesitations, people changing their minds mid-sentence, background noise.
And the messy stuff.
Right. It tests the messiness of actual human thought happening out loud.
And Gemini 3.1 Flash Live scored 36.1% on that challenge. Now, I know, on paper, if you just glance at that number, 36.1% sounds like a failing grade.
It sounds terrible.
Right. Especially when you see that non-dialogue models, the ones that just ingest a clean audio file and output a text transcript, they score over 50% on similar processing tasks.
Yeah.
So why is a 36.1% on the multi-challenge considered this monumental engineering feat?
Well, you have to look at the architecture of what is actually happening in those milliseconds.
Okay.
A non-dialogue model has the luxury of time, and it has completion. It receives the whole file, it processes the semantic meaning, and it outputs a result.
Like translating a recorded voicemail.
Exactly.
Mm-hmm.
But a live dialogue model has to constantly run predictive inference parallel to acoustic processing.
So it's guessing what I'm going to say while listening to what I'm saying.
Yes, and when you interrupt the AI mid-sentence, it has to instantly halt its audio output, process your new phones, discard the massive probability tree of the response it was already generating, tap, calculate a brand new semantic response based on your interruption, and then synthesize that into acoustic data.
All before I finish taking my next breath.
Exactly, all under 300 milliseconds. So achieving a 36.1% success rate in maintaining context through that level of adversarial acoustic chaos, that requires an unbelievable leap in edge compute efficiency.
And the crazy thing is, they are already deploying it. Like, Google is running pilot programs with Home Depot and Verizon right now.
Yeah, it's out in the wild.
So my earlier analogy about the bank call, it wasn't really a hypothetical. You could literally be calling Home Depot today to ask about, I don't know, drywall dimensions.
Right.
And the guy on the other end says, let me check the inventory in aisle 4, pausing perfectly because you just coughed. And you have absolutely no idea it's an algorithm.
It fundamentally alters the psychology of human-computer interaction.
It really does.
It removes all the friction. And we are seeing this exact same philosophy applied to cross-cultural communication too.
Oh, you mean the translation stuff?
Right. Yeah. Look at the rollout of Google Live Translate expanding to iOS. It's across 12 countries now, covering over 70 languages.
The technical leap there is fascinating to me because it's not just translating the text like a subtitle. It is actively preserving the original speaker's tone, their accent, and their pacing.
It's incredible.
It literally reconstructs the translated speech using your specific acoustic fingerprint.
Right.
And on the Android side, for the developers tracking this, specifically version 10.101.37, wait, let me get this right, 10.101.37.88563132.3.
Rolls right off the tongue.
Doesn't it? But in that version, they've integrated a new Google Translate practice mode.
Ah, yes.
It basically acts as a localized AI pronunciation coach for English and Spanish.
Yeah.
It listens to your phonetic output, it analyzes the micro variations in your vowels, and it scores you against native pronunciations.
And see, the preservation of prosody, which is the rhythm and intonation of speech in live translation, it's a psychological game changer.
Oh, so.
Because historically, translation tools act as a robotic middleman. You speak passionately in English, and the machine outputs this flat, sterile monotone in Spanish.
Right, you lose all the emotion.
Exactly. The emotional payload of the communication is completely stripped away. But by utilizing generative acoustic modeling to map your specific vocal frequencies onto the target language, the listener feels the urgency, or the empathy, or the humor exactly as you intended.
That's amazing.
You are bypassing the sterile middleman and forging a direct, seemingly unfiltered human connection, even though a massive neural network is aggressively rewriting the audio stream in real time.
Okay, I have to push back on the safety mechanisms here, though.
Of course.
Because there is always a catch with this level of audio manipulation. Google is embedding a synthed watermark into the output of Gemini 3.1 Flash Live.
Right, the imperceptible watermark.
Yeah, the documentation insists this watermark is imperceptible to the human ear. It's embedded in the subfrequencies, right?
That's the claim.
But if I am getting a highly targeted spear phishing phone call that sounds exactly like my CFO authorizing a wire transfer, and the conversational latency is flawless,
Yeah.
how does an inaudible watermark protect me in that moment? It feels like we are designing the perfect disguise and putting the ID badge on the inside of the jacket.
That is such a good way to put it. It highlights a massive gap between technical compliance and functional security.
Right.
From an engineering standpoint, the company has solved the attribution problem. A forensic tool can mathematically prove the audio was generated by their servers.
Sure, after the fact.
Exactly. But you are entirely correct about the point of interaction. The responsibility of verification is being pushed onto specialized detection software that the average consumer or targeted employee does not have running actively during a live phone call.
Nobody has that on their phone.
No. We are aggressively engineering the friction out of our interactions. But friction, that momentary hesitation, that robotic awkwardness, is precisely what used to keep us safe from these kinds of social engineering attacks.
It's a terrifying thought. We removed the friction. But, that leads to an even bigger question. How did these models get so unbelievably good at mapping the chaotic, messy reality of human interaction in the first place?
They didn't just learn it in a vacuum, I'll tell you that.
No, they learned it from us. We trained them.
We absolutely did.
The entire architecture of modern AI is built on the back of unseen, heavily gamified human labor. And this is one of the most fascinating economic realities we face today.
It's a hidden economy.
We think we're just playing a game or checking our email or proving we aren't a bot so we can buy concert tickets online. But really, we are performing highly complex data annotation work for multi-billion-dollar tech giants.
And we're doing it completely for free.
Completely for free. Let's look at the foundational example of this, Cape TCHA. Specifically, Google's Recap TCHA.
Right. To understand the brilliance of Recap TCHA, you really have to look at its evolution.
Take us through it.
Originally, it was used to digitize books.
Oh, right, the blurry text ones.
Exactly. You were shown two words. One was known to the system, and the other was a scanned word that the optical character recognition software couldn't read.
Okay.
By typing both, you proved you were human, and you transcribed a word for the database.
Two birds, one stone.
Exactly. But the current iteration, where you were asked to select all the images containing a crosswalk or traffic light or bicycle, that is entirely about training computer vision for autonomous vehicles.
Right, for Waymo's 6th-generation fully autonomous fleet.
Hey, you got it.
Because for a vehicle to operate safely without a steering wheel, it has to flawlessly distinguish between a shadow stretching across the asphalt, a plastic bag blowing in the wind, and an actual pedestrian stepping into a crosswalk.
They have to know the difference instantly.
And you can't just program that rule. You need a neural network to ingest millions of visual edge cases.
And identifying those edge cases requires human intuition. If Waymo had to pay a warehouse full of data annotators an hourly wage to click on photos of stop signs from Google Street View all day,
The cost would be insane.
the capital burn would be astronomical. So instead, they decentralized the labor. They positioned that tiny microtask as a security gatekeeper across the entire internet.
It's genius, honestly.
It really is. Every time you log in, you process an image, your human pattern recognition is verified, and the Waymo neural net adjusts its weights and biases by a microscopic fraction.
And it scales beautifully. But the crowdsourced labor goes way beyond clicking photos on a screen. Let's talk about Pokémon Go.
Oh, this is a great example.
Because back in 2016, Niantic dropped this augmented reality game, and over 500 million people downloaded it.
Everyone's playing it?
We were all walking around our neighborhoods, pointing our phone cameras at park benches and random statues to catch digital monsters.
And it was heralded as a massive moment for augmented reality gaming. But the secondary, and arguably far more valuable objective, was the creation of a localized spatial database.
Right.
Those 500 million players were essentially acting as an unpaid fleet of digital surveyors. By utilizing the camera and gyroscopic data from those phones, Niantic Spatial was able to build hyper-accurate 3D point cloud maps of the physical world. They crowdsourced visual slam simultaneous localization and mapping on a global scale.
And where's all that granular spatial data going today? It is being licensed by robotics startups.
Exactly.
Look at Coco Robotics. They are deploying autonomous delivery bots, and they use that exact Niantic spatial data to navigate.
Because traditional GPS architecture is fundamentally flawed in dense environments.
Right, like cities.
Yeah. If you are a delivery bot trying to navigate between skyscrapers, you experience multipath interference. The GPS signal bounces off the glass and concrete, and suddenly the robot thinks it's 3 blocks away.
That's a problem if it has your lunch.
It fails completely in urban canyons and subway stations. But if you have a dense visual point cloud map generated by teenagers hunting Pokémon for 5 years,
Which is wild to think about.
the robot can just look at the specific pattern of brickwork on a building compared to the spatial database and know its location down to the millimeter.
It's brilliant engineering, but it completely reshapes the concept of value creation.
It really does.
We are the digital bees pollinating the AI flowers, completely oblivious to the honey being harvested.
I like that analogy.
And we do this in the name of security, too. Look at spam filters.
Oh, yeah.
When you open your inbox, see a suspicious email, and click Report Spam, you aren't just tidying up your personal workspace. You are manually reinforcing the defensive algorithms against a tidal wave of generative AI attacks.
And we need that defense because the threat landscape has completely shifted. The National Consumers League recently published data showing that phishing attacks jumped 85.6% between 2024 and 2025.
Wait, 85.6% in 1 year?
Yes. And the financial devastation is tracking right alongside it. Individual losses from these attacks doubled, going from an average of $1,000 to $2,060 per victim.
That isn't a trend line. That is a vertical wall.
It is the direct result of large language models being weaponized for social engineering. The classic Nigerian prince scam, it relied on volume.
Yeah, and it was poorly spelled.
Exactly. It was grammatically awkward on purpose to filter out skeptical targets. But an LLM doesn't make typos.
No.
An LLM can scrape your LinkedIn profile, analyze the communication style of your specific company's HR department, and generate a flawlessly written, highly personalized spear phishing email.
That is terrifying.
It creates a massive adversarial loop. The offensive AI generates millions of sophisticated attacks, and the only way the defensive AI can keep its filters updated is if millions of human users constantly act as active data annotators, flagging the edge cases that slip through.
So we gave them the data, we transcribed the books, we identified the crosswalks, we mapped the physical geometry of our cities, and we curated the spam.
We did the heavy lifting.
And the tech giants took this pristine processed data and used it to build massive content generation engines.
We thought we were heading toward a future of limitless, prompt-generated media.
We really did.
But as we pivot to the entertainment sector, it turns out that dream just hit a billion-dollar brick wall. The generative media boom is definitely experiencing its first truly spectacular reality check.
Let's talk about the fall of Sora. Because a while back, OpenAI basically broke the internet when they teased Sora, their text-to-video model.
It was everywhere.
You could type a prompt like a cinematic tracking shot of a woolly mammoth walking through a snowy meadow, and the system would spit out a temporally consistent, photorealistic video.
It sent absolute shockwaves through Hollywood.
It really represented the holy grail of generative AI, didn't it? The ability to simulate reality on demand, matching the fidelity of a multi-million-dollar production with a single text prompt.
That was the promise, yes.
But the industry reporting outlines a completely unexpected collapse. OpenAI abruptly shut the entire Sora project down. They just froze it.
Yeah, they pulled the plug.
And the immediate casualty of that decision was massive. Walt Disney canceled a 3-year, $1 billion licensing deal with OpenAI.
$1 billion.
$1 billion. This was a partnership that would have integrated over 200 proprietary Disney characters into the generation engine.
$1 billion pipeline, just vaporized overnight.
Oof.
But the fascinating part of this collapse isn't a failure of the technology itself. The model worked.
It did work.
But it crashed headlong into the immovable physics of law, politics, and hardware economics.
Yeah.
Sam Altman actually outlined 3 fatal flaws that forced the shutdown, and each one reveals the ceiling of the current generative paradigm.
Okay, let's go through them. The first flaw was the massive wave of copyright lawsuits from Hollywood studios and artist unions.
Right.
And this loops right back to the unseen labor we were just talking about. When Google used our CAPI-TCHA clicks to train Waymo, nobody cared.
No one sued over traffic light.
Exactly. But when OpenAI ingested decades of copyrighted cinema to train a model that could instantly replicate the stylistic output of those creators, the original laborers fought back.
Hard.
The training data was opaque, and the legal liability of a tool designed to instantly synthesize protected IP became completely toxic for any legitimate corporate partnership.
Exactly.
Yeah.
Disney is not going to license their IP to an engine that is simultaneously being sued by every major studio for intellectual property theft.
It's bad business.
The legal architecture simply does not exist yet to untangle stylistic inspiration from algorithmic replication.
Makes sense. Now, the second fatal flaw Altman cited was the threat of deepfakes to global elections.
This is a big one.
We talked earlier about audio watermarks like Syntheni, but visual watermarks are incredibly fragile, aren't they?
Very fragile. You can crop them out, you can strip the invisible metadata, or you can just run the video through a secondary compression algorithm to destroy the signature.
So they're basically useless against bad actors.
Pretty much. So deploying a photorealistic video generator to the public during a global election cycle was deemed a critical threat to democratic processes. The risk profile was uninsurable.
Wow. But the third flaw, that's the one that truly dictates the future of this industry, isn't it?
Yes. The devastating compute costs and the sheer lack of available AI chips.
Break this down for me, because this seems like the actual bottleneck here. Why is video so much harder than text?
It comes down to the mathematical reality of diffusion models. Generating a page of text is computationally trivial.
Okay.
Generating a single static image requires significantly more memory bandwidth, but it's manageable. But video is not just a sequence of images, it is temporal consistency.
What does that mean in practice?
It means the AI has to remember exactly where a character's hand was in frame 1, calculate the physics of its trajectory, and render it perfectly in frame 2.
And it's doing that 60 times a second.
Exactly. 60 times a second while accounting for lighting, texture, and background geometry. The sheer volume of matrix multiplications required to render reality pixel by pixel at that scale is economically unviable.
There just aren't enough chips.
There simply aren't enough specialized silicon chips in the world to allow millions of consumers to generate video on demand without bankrupting the company paying for the electricity and the server time.
So the prompt to blockbuster movie dream is dead, at least for now.
For now, yes.
But looking at the broader landscape, there are visual models surviving by doing the exact opposite of Sora. They are abandoning the cinematic dream and staying incredibly narrow.
Look at what Microsoft is doing with MAI Image 2.
Right.
Mustafa Suleyman championed this model, and it recently hit third place on the Arena leaderboards. But it is entirely devoid of Hollywood ambition.
It's not trying to make movies.
No, it focuses precisely on the practical, mundane tasks that diffusion models traditionally struggle with. Accurate text rendering within an image, precise skin tones, and generating highly structured business assets like infographics and architectural diagrams.
It's corporate PowerPoint on absolute steroids.
Exactly.
And it's available through the MEI Playground and the Foundry API. And we see a similar pragmatic pivot in audio, too. Google just launched Lyria 3 Pro.
Ah, yes.
Now, the previous iteration could only spit out a 30-second jingle. Lyria 3 Pro extends that to full 3-minute tracks. But the critical evolution is the interface. It isn't just a text box anymore. It offers structural control. You dictate the intro, the verses, the choruses.
It introduces architectural control to the human user. But notice the monetization strategy there.
Oh, yeah.
Google is locking Lyria 3 Pro strictly behind their paid Gemini and Vertex AI enterprise subscriptions.
Which perfectly sets up the massive transition we are seeing across the entire industry. The tech giants realize they can't sell limitless video generation to consumers. It's legally radioactive and computationally bankrupting.
Right.
So they look at their massive server farms, they look at their scarce, incredibly expensive AI chips, and they ask, where can we deploy this power to generate an immediate, undeniable financial return?
And the answer is the enterprise. They're
Right.
pivoting entirely to B2B.
But they aren't just selling software tools anymore. They are building autonomous agents.
Yes.
And in doing so, they are triggering a highly expensive, deeply bizarre new corporate culture.
The agent culture is wild.
This brings us to the era of token maxing. Let's start with the corporate warfare driving this. OpenAI is aggressively restructuring. The internal data shows they are doubling their staff, going from 4,500 employees up to 8,000 by 2026.
That's a massive hiring spree.
And a massive chunk of these new hires are designated as technical ambassadors.
Right. And the role of a technical ambassador isn't to build new foundation models. Their sole directive is to embed OpenAI's existing agents deep into the infrastructure of massive organizations.
Like,
well, they are deploying these systems for the Department of Defense, and they are deep in integration talks with Brookfield Asset Management, which is one of the largest investment firms on the planet.
why the sudden aggressive pivot to enterprise integration, though?
Because they're losing ground.
Ah.
The RAMP AI Index data point is incredibly telling here. When massive companies are procuring AI services for the first time, 70% of them initially prefer Anthropic's Claude model over OpenAI's offering.
70%. That is a huge market share. Why Claude?
Because Anthropic has systematically positioned Claude as the structurally safer, highly steerable alternative. When you are deploying AI to analyze proprietary financial data or write core infrastructure code, you don't want a model optimized for creative writing.
Right, you don't want it writing poetry.
You want a model optimized for rigorous logic and systemic safety. So OpenAI is scaling its human ambassador force to fight a ground war for these enterprise contracts.
So these massive companies buy access to these models and they hand them over to their software engineers. And this is where the culture gets completely unhinged.
Unhinged is the right word.
We have to talk about token maxing. Now, for the uninitiated, we know a token is the fundamental unit of AI compute. But the sheer volume of consumption happening right now defies human comprehension. The internal logs show an engineer at OpenAI burning through 210 billion tokens in a single week.
Let's contextualize that number because it's hard to grasp.
Please do.
210 billion tokens is roughly equivalent to the entire text of Wikipedia, multiplied by 33,
What?
consumed by a single employee's account in 7 days.
How is that even possible? It's physically impossible for a human being to read, write, or even skim that amount of data.
Well, they aren't reading it. This is the fundamental shift from writing code to managing agent swarms.
Swarms.
Yes. The software being deployed right now like the open source platform OpenClaw, it does not sit idle waiting for a human prompt. It is an autonomous agent architecture.
How does that work?
A developer gives the primary agent a high-level goal, something like refactor this legacy database architecture to improve latency by 15% and ensure it passes all security compliance tests.
And then the developer goes to sleep.
Exactly. The developer logs off. But the primary agent immediately spins up specialized sub-agents. It creates a researcher agent to analyze the existing code base. It creates a coder agent to write the new architecture. It creates a QA agent to run unit tests.
Oh, wow.
These sub-agents run in a continuous high-speed loop. The coder writes a script, the QA agent tests it, it fails, the massive error logs are fed back into the context window of the coder, and it rewrites the script.
So it's just talking to itself.
Over and over. This loop can happen thousands of times an hour, 24 hours a day. Every single iteration, every massive error log fed back into this system consumes context window, burning millions of tokens per second.
It's the automation of trial and error at hyperspeed. The human becomes a general commanding an army of digital insomniac workers.
Yes.
And the scale of the cost is breathtaking. We see reports of an Anthropic user racking up a single monthly compute bill of $150,000 using the Claude Code Assistant. Wait, hold on. Let me just stop and process that. $150,000 for one developer's compute budget in a month.
Yep.
How on earth is management approving that? Is that developer actually generating $150,000 worth of functional code value in 30 days?
That is the exact friction point of this new corporate culture.
Yeah.
The metrics of productivity have completely detached from the final output. Tech companies like Meta and Shopify are actively setting up internal leaderboards to track which employees are consuming the most tokens.
They are incentivizing it.
They're actively incentivizing their staff to burn compute.
It's becoming the ultimate corporate status symbol. Jensen Huang, the CEO of NVIDIA, the guy literally selling the shovels in this gold rush, he recently suggested that a top software engineer's AI compute allocation should equal roughly half of their base salary.
It's wild.
He is talking about handing engineers up to $250,000 a year purely in invisible computational resources.
And Thomas Kunkus, a prominent venture capitalist, is categorizing this as the fourth pillar of compensation.
Right.
Historically, you had your base salary, your cash bonus, and your equity. Now you negotiate your token budget. We have developers like Max Linder in Stockholm openly stating, I probably spend more on Claude than my actual salary.
But this leads to the most predictable human behavior imaginable.
Oh, of course.
When you tie an engineer's internal status to how much compute they can burn, they will find highly creative ways to burn it. Which brings us to the loophole hacker anecdote, which I absolutely loved.
That was a great story.
A developer realized they could string together multiple $20 a month promotional subscriptions for an AI tool. Using this API loophole, he managed to extract $70,000 worth of Claude tokens for $20, parallelizing his workflow to run 6 massive software development projects simultaneously.
I mean, it's resourceful, yes, but it highlights the core danger of this entire paradigm. Are we measuring actual innovation, or are we just incentivizing performative digital noise?
Exactly. Measuring a programmer by how many billions of tokens they burn feels like measuring a chef by how much gas they leave the stove running.
Right.
It doesn't mean the food is good. It just means you are wasting incredibly expensive resources. If an agent swarm generates millions of lines of code while you sleep, it doesn't mean that code is elegant, secure, or even necessary. It might just be digital spaghetti.
This is the high-frequency trading of software development.
Oh, that's a good comparison.
In the 2010s, financial firms built algorithms that traded thousands of times a second, entirely detached from human comprehension, often just creating market noise. We do the exact same thing now with software architecture.
Yeah.
And the problem compounds when these massive token budgets are no longer just restricted to writing code in a sandbox.
Right. The agents are escaping the IDE. They are being deployed to manage human beings, and they are being given native control over our physical hardware.
Which is a huge leap.
Let's look at Meta. Mark Zuckerberg is actively building a personal AI director. Now, Meta currently has 78,865 employees. They went through brutal layoffs, dropping down to around 67,000, and now they are creeping back up to nearly 80,000, heavily driven by their AI division hires.
The fundamental flaw of any massive corporate hierarchy is the information bottleneck.
Sure.
Data generated on the ground floor takes weeks to filter up through layers of middle management. By the time a report reaches the CEO's desk, It has been aggregated, sanitized, and stripped of its critical nuance.
That's useless by then.
Right. So Zuckerberg believes an autonomous agent architecture is the solution to maintaining the agility of a 10-person startup while directing 80,000 employees.
So this AI director is designed to continuously ingest the workflow, the internal documentation, and the raw output of the entire company and synthesize it directly for him. And this agent culture is permeating the entire company. Meta employees are using an internal tool called MyClaw to build their own bespoke agents with full access to their private communications and project files.
And interestingly, they are also relying heavily on a tool called Second Brain, which is actually built on Anthropic's technology stack to analyze massive document arrays. But the critical escalation here, the moment the corporate structure truly flattens, is how these tools are interacting. Employees are using a platform from a recently acquired startup called Manus to let their agents coordinate directly.
Let me make sure I am visualizing this correctly. If I am an engineer at Meta, my personal AI agent, which has ingested all my current code and my schedule, might establish an API connection with your personal AI agent.
Yep.
They negotiate a timeline, they allocate resources, and they coordinate the project integration completely autonomously. And you and I just review the final commit.
Exactly. It's machine-to-machine coordination managing human output. If an AI can instantly analyze the progress of 80,000 employees, and subordinate AI agents are handling the cross-team logistics, the entire concept of middle management becomes functionally obsolete.
The machines are doing the managing.
Machines are doing the managing.
And if you think giving an AI access to your corporate email is wild, look at the physical escalation happening with Anthropic. The internal data details a new feature that feels like crossing the ultimate Rubicon. Anthropic is giving Claude the ability to natively control your Mac computer.
The Anthropic Mac takeover.
Yeah.
This isn't an API integration where the AI lives inside a specific app. This is an agent operating at the OS level. It's a research preview currently available for Claude Pro and Claude Mac subscribers on macOS, utilizing a suite of apps called Claude Cowork, Claude Code, and Dispatch.
Explain the mechanics of this, because it blew my mind. It's not just running terminal commands in the background, is it?
No, it is utilizing visual processing mapped to coordinate control.
Like it has eyes.
Basically. The agent essentially looks at your screen, processes the visual layout of your messy desktop, and then utilizes accessibility APIs to physically move your mouse cursor.
That is so creepy.
It clicks on icons, it drags files between folders, it opens your web browser, navigates to a CRM, and types data into spreadsheets exactly like a human user sitting at the keyboard.
And with the Dispatch app, I don't even need to be in the room. I can be at a coffee shop, text my Dispatch agent from my phone and say, compile the quarterly financial report and email it to the board.
Yep.
The agent wakes up my Mac, back at the office, takes control of the mouse, opens Excel, opens my email client, writes the message, and hits send. If Zuckerberg needs an AI just to filter the information from his own company, and Claude is literally moving my physical computer mouse for me while I'm miles away, who is actually working for who here? The boundaries aren't just dissolving, they've inverted.
The agent is no longer trapped in the browser. It is operating the operating system. But, there is a physical reality to all this invisible software. Claude cannot move your mouse if the computer doesn't exist. Which brings us to a deeply concerning juxtaposition regarding the hardware vessels we are building.
Let's talk about the physical hardware and the threat of what we are putting inside it. Looking at Apple's upcoming ecosystem, they are obsessing over physical perfection. They are preparing the iPhone Fold, and the engineering going into this is entirely focused on preventing the structural disasters of early folding phones.
They're deploying a seamless hinge design paired with a dual-layer UTG-UFG architecture. That's ultra-thin glass and ultra-flexible glass.
Right.
By suspending the display panel between these two distinct tension layers, rather than placing it in direct mechanical contact with a hinge, they are trying to completely mitigate the visible crease and improve long-term reliability.
They want a pristine, unbreakable physical vessel. They're also rolling out iOS 26.4, which brings these neat, localized edge compute features. You have a playlist playground that generates music cues from text prompts.
Which is fun.
You have offline music recognized in the control center, which is actually fascinating. It caches acoustic fingerprints locally on the neural engine so we can identify a song playing in a coffee shop, even when you have no cell service, delivering the result later.
Very clever.
They are adding 8 new emojis. They've got an orca, a trombone, I think a landslide, a ballet dancer, a distorted face. They even attempted to acquire Lux Optics, the makers of the pro camera app Halide, to supercharge the iPhone 18 Pro camera, which triggered a very messy lawsuit with co-founder Sebastian DeWitt.
But look at what is happening here.
Yeah.
Apple is spending billions of dollars and thousands of engineering hours obsessing over the perfection of the physical device.
Yeah.
The self-healing glass, the perfect mechanical hinge, the precise shading of a trombone emoji, the localized acoustic caching. They are building immaculate, heavily fortified glass castles.
Right. And while we are obsessing over the shatterproof glass castle, Anthropic just accidentally leaked the blueprints for an automated digital wrecking ball.
They did.
Let's look at the climax of today's deep dive, the Anthropic leak. The internal logs confirm a massive cache of nearly 3,000 proprietary documents was left exposed in a publicly searchable repository due to a configuration error in their content management system.
A simple error.
A simple error, huge consequences. These documents were independently verified and analyzed by Alexander Pols, a cybersecurity researcher at Cambridge University, and Roy Paz, a senior AI security researcher at LayerX Security.
And the architectural details they uncovered are staggering. Anthropic has been secretly testing a fundamentally new model called Claude Mythos. Internally, they refer to this architectural tier as the capybara tier.
Up until this leak, their highest operational tier was Opus. Opus 4.6 was considered the state-of-the-art benchmark.
But the leaked documentation reveals that Capybara represents a non-linear leap in capability. It wildly surpasses Opus 4.6 in complex academic reasoning and software architecture. But the critical difference, the terrifying leap, is its proficiency in offensive cybersecurity.
The internal draft blog posts written by Anthropic engineers for a future public release explicitly acknowledge that Claude Mythos poses, quote, unprecedented cybersecurity risks. Why? Because it possesses the capability to identify zero-day vulnerabilities in massive software code bases significantly faster than human cybersecurity teams can patch them.
Yes.
Now, we know a zero-day is an unpatched flaw, but break down the mechanics here. Why is Capybara so much more dangerous than Opus 4.6? What is it actually doing?
It comes down to dynamic execution path analysis.
Okay, what is that?
Previous models, like Opus 4.6, were largely pattern matchers. They could read static code and identify known vulnerabilities based on historical training data.
So it only found things it had seen before.
Exactly. Capybara operates differently. It can autonomously model state changes within a sandboxed environment. It doesn't just read the code. It theorizes millions of obscure, highly complex interaction pathways between different software modules.
Looking for what?
Looking for logical paradoxes or memory leaks that no human engineer could anticipate. It is essentially executing automated, high-speed penetration testing against novel infrastructure.
The fear has always been the master key scenario, hasn't it? An AI smart enough to scan global infrastructure, map every unlocked digital backdoor, and exploit them simultaneously.
Yes.
The internal documents indicate that Anthropic's own engineers believe the Capybara tier has crossed that threshold. The model is deemed so structurally dangerous that their deployment strategy involves a highly restricted early access phase exclusively for allied cyber defense teams, just so the defenders can brace for impact and harden their systems before the model inevitably leaks or is released broadly.
But the tragedy of the leak is that the impact has already occurred. The internal logs and independent reporting confirm a real-world breach utilizing this exact architecture.
The facts here are stark. State-sponsored hackers out of China successfully utilized an iteration of these highly capable agent tools, specifically leveraging Claude code architectures, to penetrate approximately 30 different secure organizations.
Incredibly secure organization.
We're talking major technology companies, financial institutions, and government agencies.
And the defining characteristic of the breach wasn't just the sophistication, it was the sheer velocity.
Right.
They penetrated 30 highly secure, heavily monitored organizations over a span of just 10 days.
10 days.
By the time Anthropic detected the anomalous API usage, traced the operational scope, shut down the offending accounts, and notified the victims, the data exfiltration had already occurred.
It was too late.
The AI acted as an automated reconnaissance and exploitation engine, mapping the attack surface and executing the intrusions with the speed that human defensive teams fundamentally cannot match.
It perfectly encapsulates the entire paradox of this era. We are walking around with consumer devices that are physical Marvel's phones with dual-layer flexible glass, perfectly translating our voices across 70 languages in real time without a millisecond of biological delay.
Feels like magic.
The technology feels seamless, friendly, and entirely invisible. But underneath that polished glass, the same fundamental models are being weaponized to pick the digital locks of global finance and government infrastructure at machine speed.
The invisible ecosystem is ravenous. Whether it's the sheer electrical and computational cost of an agent swarm rewriting a database while you sleep, or a state-sponsored actor utilizing dynamic execution path analysis to compromise a secure network. The real action is happening entirely out of sight, operating at a scale and speed that defies human comprehension.
What an incredible, unsettling journey today's deep dive has been. We started with Google erasing the biological delay in human communication, using Gemini to intercept and rewrite our vocal frequencies in real time.
We covered a lot of ground.
We explored the massive gamified economy of unseen labor, how our casual interactions with ChatGPT and Pokémon Go literally map the physical world for autonomous delivery fleets and train the algorithms to fight off LLM-generated phishing attacks.
Yep.
We watched the billion-dollar dream of the Sora video generator collapse under the immovable weight of copyright law and the crushing physics of compute costs.
And we tracked the massive capital pivot to the enterprise, the token maxing culture, where burning through 33 Wikipedia's worth of context window in a week is viewed as a corporate status symbol.
Yeah.
We examined the architectural flattening of management as Mark Zuckerberg deploys an AI director, and we saw Anthropic literally take control of the physical mouse and keyboard of the Mac operating system.
Ending, of course, with the capybara leak. The realization that the models operating beneath the surface are now capable of outpacing human cybersecurity. It's a landscape where human intuition is simultaneously the most valuable training data required to build the machine and the most vulnerable bottleneck in defending against it.
Sobering thought.
Which brings me to a final thought I want to leave you with today. We talked earlier about Thomas Tungus and this idea of the fourth pillar of compensation. Companies handing software engineers $250,000 token budgets to command these autonomous agent swarms. Right. Now, if you are an engineer listening to this, you might be thrilled at the idea of commanding that kind of computing power. But consider the long-term economics here. Tokens do not build equity for the worker.
No, you don't.
They aren't company stock. They aren't cash depositing into your retirement account. They are simply the fuel required to make the machine run. If an OpenClaw agent swarm running 24 hours a day, 7 days a week, natively controlling a Mac, can execute the equivalent output of 5 senior engineers, and the corporation owns the agent, owns the API access, and pays for the compute fuel, how long until the concept of a human software engineer transitions from being the core engine of the tech economy to a luxury artisanal title?
When the machine can do the labor, and the machine doesn't require a salary or equity, the human temporarily elevates to the role of supervisor. But as we saw with the agents communicating via Manus at Meta, eventually the machines learn to supervise each other.
The invisible architecture just keeps building itself right beneath our feet. Thank you for joining us on this third deep dive into the AI core. Keep questioning the technology shaping your world. We'll see you next time.
Thank you for watching. For more professional AI insights, remember to like this video and subscribe to AI Corecast.